Hi, this is Mr. Max with part 3 of coordinate geometry, and I'm going to look at gradient or slope of a straight line. Okay, so when we are talking about the gradient or the slope of a straight line, we normally refer to as a measure of its steepness. Okay, the bigger the value, the steeper the line. Okay, so if you have your line AB and you have the coordinates point, as you can see here. Alright, so that point B is the point x comma 2 or x sub 2 comma y sub 2, and point A here is x sub 1 comma y sub 1. And the gradient is going to be the exchange in the y values divided by the exchange in the x values. So that means you take your two y values and you subtract them. You take your two x values and you subtract them. That there will be the measure of steepness of the line. Alright, so you can also swap around. You can say y sub 1 minus y sub 2, x sub 1 minus x sub 2. But you may not swap the coordinates around like this. Okay, in this case, it will not be correct. So when we are referring to the gradient, we're talking about that steepness. And we're going to use that to do a few questions and solve them. Right, so I'm going to go right into it. So the first couple of questions here, you're supposed to calculate the gradient. So well, you can just go ahead and straight up use your formula. All right, so I took the point. So you have the point 0, 0 for A, and then you have the point negative 2, 1. So 1 minus 0, and obviously my B is the x sub 2, y sub 2, and negative 2, 0. So the gradient here is a negative a half, and the gradient on this plan is also the same, it's negative a half. All right, so I took here 0 minus negative 1, which is 1, and negative 4 minus negative 2 gives you that negative 2 there, which is the whole fraction is negative. So what you realize here, if you plot these points on a point, if you have to plot them on a point, the gradients are the same, A to B and C to D. The gradients are equal. These lines therefore are parallel, okay? And parallel lines have got equal gradients. And that is one of the things you would realize whenever you're dealing with line segments and they have got exactly the same gradient. This here being line CD and that one being line AB. Right, so let me bring in another question. You're supposed to find a gradient and it's similar. So the way you calculate, so again, you can start with negative 2 minus 0, always the y's, then the x, so identify your y and your x so you don't make a mistake. The gradient, this line here is going to be 1/4. And if you do the same for the other one, the gradient of this line, if you punch in 4 minus negative 4, which is 8, negative 2 minus 0, which is negative 2, and negative 2 into 8 gives you negative 4. So you look at these two gradients here, okay, and we have to plot the points E, F, G, and H on a Cartesian coordinate system. You will realize that the point they intersect is 90 degrees, and therefore these two lines are perpendicular to each other. The point where they meet is 90 degrees. The gradient of one line times the gradient of another line will give you a product of negative 1. So what that means, if you take the gradient of the line 1/4, if you take the gradient of this line here, okay, so you've got 1/4, and you multiply that by the gradient of the other line, which is negative 1/4, which is negative 4, rather. When you multiply them, you get a product of negative 1. That tells you that the gradients of this line is perpendicular, so where these lines are meeting, they are going to meet exactly at 90-degree angles. So this is the type of thing you should also remember. So let me bring in then just a few notes here so you to know exactly what I'm referring to. So suppose there's some other important lines. For example, a horizontal line, the gradient is 0. Okay, and in such cases when the gradient is 0, it's when you have a point where the x values or the y values rather are the same. So if I give you the point 4, 0, just make an example, and I give you the point 5, or even negative 5 for that matter, 0, and I ask you to calculate the gradient here, you would realize that on top you're going to have 0, okay, and obviously whatever you have here under will be a value. So when you have 0 on top and whatever value here, the gradient is equal to 0. And for the gradient of a line to equal to 0, that line is going to be taking the form of y equals to some number. Like in this case, the gradient y equals to 0 would be the x-axis. Alright, so this particular lines, as long as they are horizontal lines, the gradient is equal to 0. That is one of the things you should not forget. Another one that I want to talk about is a vertical line. A vertical line, its gradient is undefined. And the way we can explain a vertical line there is we can explain a vertical line by perhaps looking at two more points. So suppose I bring the point 0, 1. So this is my point A, for example. We'll just correct that nicely with my pen. So suppose this is my point A, and my point B is the point 0, let's say, -5. And if I ask you to calculate the gradient of line AB, you take the exchange in y, so that could be 1 minus -5, if I start with point AB. But here's the problem now. I am having a value under the denominator that is 0, and you may not divide by 0, okay? So this here is simply not possible. And because that is the case, the gradient of a vertical line does not exist. All right, so very important that you will know that when you have lines, vertical lines, its gradient will not exist. Lines that are cutting the x-axis, like for example, if you have a line here, okay, or a line there, all right, okay. So these type of lines, their gradients do not exist. It's just one of those things that you have to revise whenever you're dealing with such questions, so you don't make a mistake of calculating the gradient of a horizontal line and say it doesn't exist, and saying the gradient of vertical line, say it is equal to 0, and that is not the case. All right, so we already spoke about beginner lines, and we also spoke about parallel lines. The gradients for parallel lines are exactly equal, and the gradients for perpendicular lines, then when we multiply, the product is -1. So if you have a gradient of a line and the gradient of the line is 5/4, okay, then the gradient of the other line should be -4/5. Okay, have a gradient of another line is -3, and the other one, the gradient should be 1/3, reciprocal, and also the sign should change. Okay, so they both are reciprocal functions of each other, and the signs are negative. Okay, one sign will be negative, one sign will be positive. That's one of the things you should remember. All right, of course I've did a video based on that in the past. Okay, so let me bring a question in here. So we have got question 3. They are saying the gradient of a line joining the 2 points here is equal to 2/3. So there is a missing x value here at Q. So you can find the gradient of Q. So obviously I'm identifying which one will be my x sub 2 and y sub 2 and so on. Now I take then my value for 7 minus 3 over k minus 2. Well, it equals to 2/3. So you can do a little bit of 7 minus 3 gives you 4. Okay, and when you multiply that 4 times 3 when you do your cross multiplication, and obviously you end up with an equation that you can solve. So some of you can multiply the 2 into the k and -2. I simply just divide it into 12. It's much easier, but whatever the method, you should arrive that the value of k should be equal to 8. So I've got a few more that we can look at. Right, so the fourth one here is something similar like that, but here you are told that you are supposed to find the gradient of a line passing through this point here. But the gradient is given as 3 rather. So the point A is 3k, 8. The point B is k, -3. So we have to find the value of k. We know what the gradient is, all right? So if I could identify my particular points and I sub into my formula, then I know that -3 minus 8 over k minus 3k equals to 3. Well, if you clean that up, -3 minus 8 is -11, and 2k under, -2k under. So you can do some cross multiplication And you obviously realize you get 6, negative 6k equals to negative 11. And to find k, you divide negative 11 by negative 6, and you find that mixed number 1 and 5 over 6. I have another one here, and here they are saying, very important, that these points are on a straight line. So what you need to understand is that when points are on a straight line, it means the gradient is exactly the same. Okay, so once the gradient is exactly the same, it should not be a problem. So you can find the gradient of AB, and then in order for you to find the gradient, the point K, you can take that gradient, and then you can use point AC or BC in order for you to find the gradient. Okay, so what I refer to is I found the gradient of AB. When I do my substitution, I find that the gradient is equal to 1. And if that is the case, then I can find the gradient. I chose to take BC, or you can also take the point AC. Ultimately, you'll get to the same answer. So if I take BC and I take K minus negative 2, 8 minus 3, well, if I solve that equation, obviously 2 negatives in the middle becomes a positive, then you get K plus 2 is equal to 6, or 5 rather, because 1 times 5 is 5, and now you get K by simply subtracting 2, and K equals to 3. And that is how you do this particular question. If it's a bit too fast, pause the video, and then you can at least have a look again and try to attempt to solve the question on your own. Right, so my sixth question here, I've got coordinates of D and E and F. So D is the coordinate 6, negative 11. E is the coordinates P, negative 9. And F is the coordinates 2P, negative 3. So they are saying that the gradient of D to E, or DE, is equal to the gradient of EF. So eventually we are dealing with parallel lines here. But the objective is to equate things here. So when we equate, I'm going to take, obviously, my DE, and I'm going to let it equal to EF. Note the gradients are equal. So I've started with negative 9 minus negative 11 and P minus 6. I'll clean that up. I'll get 2 on top and P minus 6, and I put P minus 6 in brackets. Okay, because I'm going to do some cross multiplication. Negative 3 plus 9 gives you 6 here. Right? Of course, a negative give you a positive. And 2P minus P is just going to be P. If you cross multiply, you eventually end up with that. Multiply over the 6. And then you have got to collect the like terms and then find the value of P. And you realize that P is equal to 9. So my last question here, you have got a line segment joining A, B, they intersect at the y-axis. Whenever that is the case, you must remember, whatever line you have, and this is your axis, for example, so that's the x-axis, for example, and that is the y-axis. So when a line, any line for that matter, intersect at the y-axis, all right, so no matter how that line goes, this point here of intersection, the x value is equal to 0, okay? So we don't know what is the y value, so I'll replace that by a k. And that is what I'm going to refer to in my next point that you are seeing here. All right, so obviously we are going to find k, and in order to find k, we are going to definitely take the gradient of AB. Once we have the gradient of AB, which is negative 9 over 11, okay, because the lines are intersecting, they're just saying intersect, they're not saying perpendicularly so intersecting lines at that particular point, they are the same, the equations are equal, so you can then find k by equating the gradient to either using a and the point C, which I already decided, point C, remember, point C is the point 0, k, okay, this is my point C here, so I can use AC or BC. So I've decided to use AC, and I'm going to use the value of AC, or the gradient of AC, or whatever the value of AC, let it equal to the gradient of negative 9 over 11, because remember, as I said, when lines are intersecting at the point of intersection, the equations are exactly the same, they will share the same gradient. Okay, so once you are here, you can clean this up. You get k minus 7, put it in brackets because you have to do cross multiplication of some sort, as I've done here. And now I'm going to get 11k minus 77 is equal to negative 54. If you clean that up, you're going to get k equals to 23 over 11 as an improper fraction, or you're going to get 2 and 1 over 11. So rather you can keep it like that. But remember the question asks us to find the coordinates. And I know that 0 is there, so my coordinates is going to be the point 0, comma 23 over 11. Okay, so the next video that I'm going to upload is going to be 2 left on the series. It will deal with finding the equation of a straight line, and then also you're going to get at the same time a video that deals with your coordinate geometry that we apply to quadrilaterals, and also maybe attach on that you're going to see me do quite a number of examinations questions in order for you to understand this topic.